looking at our next section, section 6, which is the last one from this chapter, we're looking at what are called regular polygons. And so regular polygons are polygons that are equilateral and equiangular. Okay, so they are convex polygons. So again, they don't have that cave. Okay, so they look something more like this. Okay, that's convex. Concave, if you remember, looks something like this. Okay, they have that cave built into them. So they have to be convex, and then they are also equiangular, equilateral, which means that they have equal sides, and they must also be equiangular, which means they have equal angles. Okay, so they have to have both of them. So all the sides must be the same, and all the angles must be the same. If neither of those are true, then it's not regular. Okay, now all the stuff we're going to talk about this deal with just regular polygons, not all other polygons. So this is specifically with regular polygons. So you need both those equilateral and equiangular properties in your polygons for these to work. So the first thing is dealing with the measure of the interior angles. Now, any type of polygon that you have, if it's a quadrilateral, which is 4 sides, or a square, which is a quadrilateral, or a triangle, or a pentagon, or a hexagon, or an octagon, or a nonagon, all those. When you're trying to find the interior angles, what you're going to do is first you have to find the sum of the interior angles, which a couple lessons back we talked about that was find the sum of the interior angles. N minus 2, so the number of sides minus 2 times 180. Triangle would be 3 minus 2, 1, 180. Quadrilateral would be 4 minus 2 times 180, 360. Pentagon would be 5 minus 2 times 180. And then what you're going to do is if you know that the sum, so like this one has to be 360, this one has to be 180, this one has to be 540, okay, what must the sum of each of those angles be? Well, since they have to be equal, we want to take those numbers and divide them by how many sides we want, or how many angles we have. So how many even groups do we want? The first one we want 4 even groups, so that means everyone would be 90. The next one we want 3 even groups, which means everyone would be 60. And the last one, we'd want 5 even groups, which puts us at 108. Okay, so each one of these would be 108. Now, as you notice, the more sides you have, the larger those angles become. So if you get more and more sides, what ends up happening is that those angles open up more and more and more and more and more. Now, if you try to think of something that has as many sides as possible, so you can think of like a circle. So you can think of a circle having an infinite number of sides. That means that each of their angles would be as close to 180 degrees as possible. Okay? So it'd be as close to 80 degrees, 180 degrees as possible, making it almost a straight line all the way across, but it's not really. It just kind of looks like it. Okay. Now, if you want to find the sum of the exterior angles, which if we remember, the sum of the exterior angles must always be 360. So no matter what shape it is, if you add up all the exterior angles, it has to equal 360 degrees. So as you get more and more sides, what happens is that that angle on the outside becomes smaller and smaller and smaller until it basically becomes nothing, depending on how many sides you have. And so if we have that and we want to find what is the measure of all the exterior angles in a regular polygon, remember these have to be regular, we're going to take 360 and we divide it by how many sides, because 360 is always the total. The interior changes based on the number of sides, but the exterior does not. So the exterior is always going to be 360, and then you divide it by how many ends there are. Okay, so that would be for those. Okay, so with these shapes, what I want you to do is I want you to take a minute and pause the video and try to find the measure of the interior and the exterior for each of the following. All right, so with the heptagon, so the heptagon has how many sides? The heptagon has 7 sides. So to do the interior, we would end up with 5 times 180 divided by 7, which means that our interior angles for our heptagon would be about 128.57 degrees, and that's for the interior. Okay. Now the exterior is easier. You just go 360 and you divide that by 7 because there's 7 sides, putting you at 51.43. 3 degrees. And that's for your heptagon. For your nonagon, okay, nonagon, remember, is 7 sides, or 9 sides, not 7, 9. You would go 7 times 360 divided by 9, which gets you 280. So every angle in a nonagon is 280 degrees, while the exterior angles in a nonagon, oh wait, no, that can't be right. Can't be 280 degrees. That's obviously not right. It should be 140 degrees, so it should be half of that. 140 degrees, which means that our exterior angles should end up being about 40 degrees each. Okay. 15agon, you'd end up with 13 times 180. Divide that by 15, and you get 156. And then our exterior would be 360 divided by 15, which gets us 24. And for the last one, 34agon would be 32 times 180 divided by 34, gets us 169.41, and our exterior would be our 360 divided by 34, putting us at only about 10.59. Okay. Now, as you see with these interior and exterior, if you add each one of these across, if you add these up, you see you would get 180 for every single one, and that's always true. When you add an interior and exterior angle, they have to be 180 degrees. They can't be anything else. Okay. All right, that's the end of that section, which also means the end of this chapter. Okay. So this is your homework. Make sure you work on that and finish it up.